parabola from its equation using the key features of the quadratic. Firstly, we look at our equation, y equals negative 21, take 4x plus 2 plus x squared, and we see that it's not in the standard form we're familiar with, which is y equals ax squared plus bx plus c. So let's rearrange it until it is in that form. And that's y equals x squared minus 4x minus 21, where our a is 1, our b is minus 4, and our c is minus 21. The first of the key features we're going to use to sketch is the y-intercept, which is found when the x coordinate is made 0. 0 squared minus 4 times 0, that's what 0. Take 21, or our y-intercept is just that c on the end. So in this case, the y-intercept is negative 21. The next key feature we need are the two x-intercepts. We assume it's going to be 2. It could be a double root where we have 2 of the same solution, or it could have no solution. So to find our x-intercepts, we need to make y equal to 0. And so we substitute that into our formula. I'm going to write it the other way around because we're more familiar with it that way. And that is equal to 0. So now we need to factorize. We're looking for two numbers that have a sum of minus 4 and a product of negative 21. Numbers that have a product of negative 21, negative 7 times 3, that does give us negative 21. Negative 7 plus 3 does give us negative 4, so that's our pair, negative 7 and 3. We can factorize this as x takes 7, x plus 3. Now we're trying to find out what the two x-intercepts are, so we need to solve this for our two x's. We have the product of two factors and they equal 0, so we can use our null factor law, which tells us that if we times two things together and get 0, one of those two things has to be 0. So it could be the first factor, x minus 7 equals 0, or it could be the second factor, that x plus 3 equals 0. So we solve for our solutions and we have x equals 7 as one x-intercept and x equals minus 3 as the other x-intercept. Next, point number 3, we need our axis of symmetry. That's our third key feature, which we can find as exactly halfway between the two x-intercepts, or using our formula negative b over 2a. Now the b and the a come from our standard form, which we've written up the top here. A for us is 1, b is minus 4, and c is negative 21. So negative b will be negative minus 4, two negatives there, over the top of 2 times 1. Minus minus is positive, 4 over 2, which equals 2. So our axis of symmetry is at x equals 2, which brings us to our fourth key feature, which is the turning point, the maximum or minimum of our graph or of our parabola. It's got an x coordinate and it has a y coordinate, x and y. The x coordinate of our turning point, it's really easy. That's the same as the axis of symmetry, so 2. The y coordinate, we have to use our equation to work it out. So we substitute x equals 2 into the equation and we have y equals 2 squared minus 4 times 2 minus 21. And so we have 2 squared, so 4 minus 8 minus 21 gives us negative 25 for our y coordinate of the turning point. So we've got the 4 key features we need for sketching our parabola. Let's draw in our y and x axis. The y-intercept is negative 21. Put that down here, negative 21. The two x-intercepts are negative 3 and 7. And there and there. Our axis of symmetry is at x equals 2. And our turning point was at the point x equals 2 and y is minus 25. So put that down here, 2, negative 25. And so we can sketch as neatly as we can our parabola. Oh, whoops, we've lost it there. We can sketch our parabola using those key features. There we go. A few extra lines there. And there's our parabola drawn from this equation.